So now we come on to the next question, which is based on graph. In the question you have been given a displacement time graph, and this is what the graph is. The question is that you have to calculate velocity of the body at different points. First is from 0 to 5 seconds, that means in this portion. Next is from 5 seconds to 7 seconds, that means this portion. And the third is 7 seconds to 9 seconds, that means the last portion. First we will find velocity at these three different regions, okay? And then we will find the average velocity during the time interval 5 seconds to 9 seconds. That means from this portion to this portion, okay? We'll have to find the average velocity. So let us begin with the first part. We'll first of all find velocity of the body in these three different regions. So how do you find velocity from a displacement time graph? We find the slope. So in order to find the first part, the velocity from 0 to 5 seconds, that means in this part, if you remember, the slope is calculated by using the formula delta y upon delta x. However, there are other proper methods, but in class 9 standard we'll teach you this only. So delta means change. That means there is one initial point and there is one final point. So if you concentrate on this part of the graph only, this is the initial point and this is the final point. So initial point is at origin, that means 0, and final point is 3, that means final point is here, that means 3, right? So initial point is 0, final point is 3, and this is on y-axis, children, okay? So y2 minus y1 means final point minus initial point, which is 3 minus 0, right? Divided by delta x. Delta x means x2 minus x1. Now corresponding to y2, which is 3, what is x2? It is 5. So here I'll write 5 minus y1 is 0. So corresponding to this point, what is x1? x1 is also 0, and therefore it is 3 upon 5, which is 0.6 meter per second. It is 0.6 meter per second. That's the answer of part 1. Similarly, we'll find the velocity in this region from 5 seconds to 9 seconds. Now always remember, whenever you get a horizontal graph, the slope of the graph is always 0. That means velocity from 5 seconds to 7 seconds is 0 because it is a horizontal graph, and a horizontal graph will always have 0 slope, and hence the velocity is also 0. Now what do you mean by when we say that velocity is 0? It means that the body is at rest, right? Now third part, from 7 seconds to 9 seconds, velocity from 7 seconds to 9 seconds. Again we'll find the slope delta y upon delta x, which is y2 minus y1 upon x2 minus x1. So what is y2 here now in this region, you tell me? This is the initial point, this is the final point, right? The graph goes like this, that's why. So y2 will be 7 and y1 will be 3. Am I clear? On the y-axis, from this point to that point, y2 is 7 and y1 will be 3. So it becomes 7 minus 3. Now corresponding values on x-axis we will take. It is not that random any value we'll take corresponding values only. So corresponding to 7, the value here is 9, which is x2. So x2 is 9 minus, corresponding to 3, the value here on the x-axis is 7, so 9 minus 7. So 4 upon 2, which is 2 meter per second, and that's the answer of part 3. Okay. Now in the next one, calculate the average velocity during the time interval 5 seconds to 9 seconds. That means the time interval from 5 seconds to 9 seconds. That means the graph begins here and ends here. In this entire region we have to find the average velocity. So what is the formula of average velocity, children? Average velocity is total displacement upon total time. So what will be the total displacement from 5 seconds to 9 seconds? At 5th second the displacement was 3. At the end of 9 seconds displacement was 7. So how much is the total displacement when the body moves from this point to that point? 7, 3, from point 3 to point 7, it is 7 minus 3, right? That's the total displacement. Now from 5 seconds to 9 seconds, what is the total time? Total time means the time duration we have to find. So that means 9 minus 5. Okay. So 7 minus 3 is 4. 9 minus 5 is also 4, which is 1 meter per second, and that's our answer.